material to review some of the things that we feel are pretty important for you to move along into this next chapter. So probably have a quiz again on Friday of this week, okay, if I had to guess. And then when we're done with the whole module, then probably early next week, my guess would be Tuesday, possibly Wednesday, you just do a test on the whole module, okay? And then we can move along to some newer stuff. What this gets into, you can kind of look and see, is good old function notation. So something that probably last year was new to you, that you hadn't seen sort of before Math 1. And sometimes people do still have kind of an issue with this. So when we talk about function notation, so a function can be written as an equation. When a function can be written as an equation, remember most of our equations have y. So like this would be really familiar to you. Kat was talking about it a little bit yesterday, this whole little y slope-intercept form where there's an x and a y. As long as our equation is a function, we can replace that y with some sort of function notation. The most common is the f. And the y and the f of x are basically the same exact thing. They're more descriptive. So if we now graph multiple lines, we can call one of them f, one of them h, one of them g, and then we know which one we're talking about. It's more specific. When we use this notation, this f with the parentheses f of x, we just got done doing a little quiz where if I did like x with the parentheses and a y, that we talked about how that implied there's multiplication here. That doesn't mean multiplication when we're talking about this notation here. We are not doing f times an x. That is read as f of x. That's how we would read that. It's not a product, all right? So that's what this is indicating here, not multiplying those together. All right, then it says replacing y with f of x is called writing a function in function notation. So the first thing that's the first thing we want you to do. And then what we want you to do with that is, if this is our function, so make this nice and big so we can see it. If that's our function, what we are looking for then is a bunch of values. So this is basically your y, and we want to know what's our y value for f of negative 2. So all that means you're going to do is you're going to take this function here, and instead of 2 times x minus a 3, so I put parentheses, notice I didn't put anything in there. Notice how instead of f of x, I now have f of negative 2. What that is telling you is we want our x to become a negative 2. So wherever you have an x on the other side, in this case it's right here, we want to substitute in a negative 2. Okay. Then we still write this as f of negative 2 would equal, now we evaluate this sort of like what we did on our last little quiz. You would do a negative for take away 3. So that we would now say f of negative 2, which is our answer, that's what we are ultimately looking for, is equal to a negative 7. Negative 4 take away a 3. Then what this is giving us, so you would have done this a little bit last year. If I now ask you what point this is, like x comma y, the whole little f of negative 2 equals a negative 7 is telling us that our x value was the negative 2. And then when x was a negative 2, we get a y value of negative 7. So function notation, this right here, f of negative 2 equals a negative 7, means the exact same thing as what you're more familiar with when we write it as a point. These mean the exact same thing, okay? It's just when x is 2, negative 2, what y value do you get? All right, and then that's how you evaluate. Yes, sir?
Well, we don't use f anymore.
Say that one more time.
We don't have to use f anymore.
You don't have to use f anymore?
Yeah, that.
I would want you to use f. So like if this is our problem on like a quiz or something, and I say find f of 7, yeah, I would want you to, go ahead and say f of 7 equals, and then plug it in. The reason I'm just showing you this right here is so you can kind of relate that to something that you're probably more familiar with and how this is just a different way of writing it, okay? So B, plug in your 7. So I'm taking the same exact function right here, and I'm going to let this x be a 7. I'm going to let that x be a 7. So I would now say that f of 7 is equal to 2 times 7, which is a 14. Subtract that 3. So we would then say our functional value when x is 7 is 11. All right. And then, all right, so Juan, what point would that then be? If I ask you, plot that point on an XY plane.
It would be 7 and 11.
Good. So if we wanted to plot this point on an XY plane, it's really just the point 7 comma 11. It's a different way of expressing it. Okay. All right, and last one. What do we got? 2x minus a 3. So we're going to do 2 times x minus a 3. So that f of negative 4 is equal to a negative 8 minus a 3. This is what we were doing yesterday a little bit, what you would have done for homework last night. You gonna give me this, Jackson, or you got a question?
Yeah, sure.
I do, right behind you. There's one outside the door. One of them is really good, one of them is not good. But I think that was the one that worked well. All right, so negative 8 minus that negative 3, then they're the same signs. So we add them up. 8 and 3 make 11. You keep the common side of a minus, so that should be a negative 11. All right. Okay, remembering all this. All right, do the second one then. Do the k of x, do 0, negative 1, and 5. Let's see if we can get through all of those. How's it working? Okay. Will you do me a favor? Is there one outside now too? Open up my door. I'm trying to remember. Is there one right outside the door too? Okay. One of them is really good. The other one not so good. I don't know why we have one on one side, one on the outside. We do. Here we are. The mysteries. All right, let's see what we got here. So letter D, Fabian, we're going to take the 0, plug that in. What's 7 times 0, Fabian?
0.
All right, and then plus a 1. So what's 0 plus 1?
1.
Yeah, just a 1. All right. You don't have to write it as a point. So if you wrote it as a point, that's fine. I'm not really asking you kind of what Juan's question is. I'm not asking you to write it as a point. I just want you to kind of understand that's what we're finding. It's just a different way of defining a point. All right. Good. All right. Let's do Sarah. K of negative 1. So we're going to do 7 times that negative 1. All right. What's 7 times negative 1, Sarah? I'll do this. Ooh. It happens to everybody, Sarah. Happens to everybody. Yeah. So negative 7. And then we want to tack on that extra 1. So now on your feet, or like thinking on your feet. Sarah, what's negative 7 plus 1?
Negative 6.
Good. Negative 6. All right. So that should have been negative 6. All right. And last one, the nicest one here, probably. All right. Riley. Because I like that name a lot. Is it negative? Was it a negative? What? Yeah, it's just 7 and 5, right?
Yeah, negative 7. It's negative 7.
Is it negative 7? Oh, I wrote this one's wrong then, right? Sorry. My bad. Thank you, Riley. All right. My bad, Sarah. Let's go back to this guy. Okay, fix this one. What's a negative 7 times a negative 1 now, Sarah?
7.
Good. And then plus 1. Yeah. Is that what you were giving me in the beginning?
Yeah.
Okay. Yeah. You're good. Yeah, you're good. Okay, so now this guy, Riley, negative 7 times 5. Good. And then plus 1. Good. So that should be a negative 34. All right. The next ones. The only difference in these next two is if we start having multiple x's. So if you kind of look over here, remember how this is a quadratic function? Remember the name of that? You talked about that very briefly. We're going to do a lot of that this year. But we now have multiple x's. So if I want to find h of negative 3, so here's my negative 3. I have an x here and I have an x there. You need to plug it into both. Do that for me real quick, because this one I would actually, if I were to put this on a quiz, so when we do quiz on Friday, if I were to put this one, I would anticipate this causing some problems for people. So see if you're one of those people. All right, and the reason I would anticipate this being an issue for some people is there's a big difference between doing a negative 3 without parentheses and squaring it, because on the calculator that'll give you a negative 9, and putting the negative 3 with parentheses and squaring it, that's going to give you a positive 9. All right, so that's why you just want to be really careful if you're throwing these into your calculator, okay? So when we look at this, wherever you have an x, we want to square the x. So if our x is the negative 3, you want to make sure that the negative and the 3 get put into that parentheses. And then the same with this next one, throw in this negative 3, and then you just got to be careful with all of your signs. So h of negative 3, so I have it in that calculator. If you use your calculator here, just be careful. You need to make sure you're using the parentheses just like we have written. That'll give us a positive 9 versus the negative 9. All right, we're doing a negative times a negative, so that's why that's a positive 9. This is another negative 3 times a negative 3. That's also a positive 9. And then tack on that 5 at the end. Henry, question? Yeah. And then h of negative 3 would equal 18 plus 5, 23. So if you got that, that's good. That's one that I would consider, I would anticipate some mistakes on that if I had given that on a quiz. Okay. Now, the next one should be nice because you're just plugging in a positive number, so it's a little more straightforward, but same process. You're going to do x squared minus 3x plus 5. All right, so wherever you had an x, you're going to substitute in the x value of 5. So it becomes 5 squared minus 3 times 5 plus 5. So we got a lot of 5s going on here. All right, Woodley, take us home, Woodley. What is 5 squared? Good. And then the negative 3 times 5 is a negative what? Good. Good. 15, negative, and then 15. And then we tack on that 5. Uh-oh. There we go. All right, 25 minus 15, Woodley. What is it? Yeah. Did you say 10?
Yeah.
Okay, 10, and then an additional 5 is 15. All right. Okay, the next one, I just want you to do C. I just want to make sure we can do the negative, and then if you can do C, you can definitely do D. So plug C in, see what we get. So this was x squared minus 5x. This is telling us to plug in a -2. So wherever we have a -2 or an x, we're going to replace that with a -2. All right, and then get that real quick. I kind of want to see if you get the right answer. So we want to evaluate that. A lot of weird stuff going on with the signs to be careful of. What's that? Oh yeah, nice. Thank you for catching that. All right, then I didn't even think Mariah this time. I knew it was Maria. So Maria, what's this -2 square going to give us?
I got 4.
Good. And then the +5 times a -2 would be what?
-10.
Good. And then minus that 3. So when we put all of that together, what'd you get, Maria?
-9.
Good. Should get -9. Okay. If you got it, good. All right. Not that these are hard, but when we start trying to square that negative, substituting in negative numbers, it's easy to kind of make a little mistake. Okay. All right. Next one. Fill in that table. However you think you would fill in that table. Fill that thing in. And so here's your function, and then using that function, give me the functional values at those x coordinates. That if you're really on the ball after a long summer, tell me what type of function that is once you have it all written down. So fill those in. At least fill in the first 3 or 4, and then we'll come back together and see how you did it. Here's what I'll actually have to do. Remember last year you did name different types of functions? You would do that like as looking for patterns. Tell me what pattern you are. What's that? No. That one's fine. Oh, I'm sorry. I meant one of these answers was wrong. Actually, two. I'm sorry. I didn't mean to look for one. I thought one column was wrong. Let's go with it. Walk me through it. What's 5 times -1? And then decrease by another 3. Okay, getting there. How's that side, Mr. Kubitz, about done? Okay. Okay, so let's fill these in. There's some different routes we can take to filling this in. So I'm kind of curious. What I'm seeing a number of people do, which is totally fine. Nothing wrong with this at all. Is they're taking each one of these values, whether they write it down, whether they put it in the table, whether they're kind of doing it in their head, and they're just plugging it into this. And that's what we did earlier. So perfectly valid. So f of -2, this would be a -10 decreased by 3. You should have gotten this to be a -13. That's probably what you need to do no matter what for -2. And then most people go to f of -1. They do the same thing. 5 times a -1 minus 3. That should have given you a -8. So we're going to fill that in. And then let's do one more. So let me do f of 0, because that's short and sweet. 5 times 0 minus 3. You get 0 minus a 3. So -3. Okay. Let's fill in the rest of those as we talk about what type of function is this. Okay, you can answer that question, Kat?
Yes, it's a linear function.
Good. It's a linear function, so write that down first. Hold on, Kat, and then I'll have you explain. So last year you dealt with multiple types of functions, probably the most common. You did this endlessly last year. You do this a lot in Math 1. So it's linear, so write that down. And then Kat, how would we have known from these first three that this is a linear function?
First off, a big indicator is the fact that they all have a constant. They have the same, not the rate of change, they have the same slope. It doesn't get larger or smaller. Also, another big indicator is the fact of the 0 value. When 0 is x, the value is the same as y is the same as it shows in the equation. 0 is negative, y is -3, and 0.
Okay.
And that's your equation.
All right.
Also, this can lead us to do another way. All you have to find out is 0, and now we use a linear function. You can just literally just add.
If once we know it's a linear function. Yeah, so let's go back to what you said at the very beginning, because that's the very first thing you said is what I was kind of looking for. She said constant. What you would have probably said more so, it's same thing as common. And then it was a common, she said rate of change / slope. All of those are 100% correct. There's a different word you guys probably used last year when you first started identifying arithmetic and for sequences and then linear functions. It was a common what? Starting with the letter D. Yeah. Difference. Remember you would talk endlessly about a common difference? So that's what she's saying when she says there's a common rate of change. Aren't we increasing by 5? We're increasing by 5. And if we know then that there's a common difference here, for every one integer I go up, so I'm going up 1, up 1, up 1, I increase by 5. So I would know this has to be 2. I know this has to be 7. And I know this has to be 12 if I just continue to add that common difference or the common rate of change. Okay? All right, so that's how we know that this is a linear function, because we have a common difference. If we graph this, it will also show this. So let's graph a few of these points because they won't all fit. So let's graph the 0, -3. And then graph 1, 2. And then 2, 7. Yeah, I messed up one of them here. And then we would know graphically, the reason we use the word linear, right, is because the word line appears in it. So they would line up in a line. So that's another way to know that we're dealing with a linear function, because these all now line up in a nice straight line. Okay. So a lot going on there. Common difference. We can do our functional values, get those, understand that it's going to be linear. All right, all that good stuff from last year. All right, next one. Before I have you fill this in, because filling this in, there's some bizarre stuff going to happen here. What did we call this kind of a function? Remember what this was called last year? You really only dealt with 2 major functions last year. And you would have did them over and over and over. One of them was linear, and then what'd somebody say? It's non-linear. I would agree with that. We can be more specific, though. Is that decimal? Okay, quadratic, that's good. So you did deal with 3. Quadratic, you didn't deal with a ton. That's really what we're going to deal with a lot here in this next chapter. This is a quadratic when we have a power of 2. That's a quadratic. So good. That now we've named 2 of the 3 you talked about last year. Now we're looking for the third one. And the third one is what this guy is. Maria, what is it?
Arithmetic.
Okay, arithmetic. Yeah. So good call. So arithmetic. So at the beginning, you would have dealt with arithmetic versus geometric. Arithmetic is pretty much the same as linear. Remember how you guys did continuous versus discrete? If it was a discrete, just a sequence of numbers, it was an arithmetic sequence because it had a common difference. Once it started to becoming continuous, like this line, then we switched the name to linear. So arithmetic and linear are kind of the same idea. Okay. So we're still waiting for that third one. That's good though. We're remembering some stuff. Now let's see if we can remember the right stuff. Anybody? Get your prize or something? Starts with it. Good. Exponential. Now, just since kind of Maria brought it up, if it's a function, if it's continuous, it was exponential. When it was discrete, what was that called? Let's do this also. This has a common. When it was exponential, or the other name here in a second, it had a not a common difference. It had a common what? Remember what we said? What you would have said? Nope, not common denominator. If we added them, it would be, we'd want that. This one starts with the letter R. Now rate of change. Ratio. Remember that phrase, common ratio? What a ratio really is a common multiple or common multiplier. So when we do this, what should happen, multiplier, we're multiplying by the same number over and over again, and we'll see what that number is here in a second. So I'm really, really curious, because this was interesting first period. Find f of -2 for me. So write down what you think that is. This one, there's more than meets the eye to this one. If you can do it without a calculator, I'd be super impressed. But if you need a calculator, you may not believe what your calculator has to tell you. Okay. Anybody confident in what you get for -2? Henry? No?
I'm not very confident, but I got negative 1.
So Henry gets a -1. So that's one option. Anybody want to confirm or throw out another option? Destiny?
It's not right, but I got
9. So Destiny is going to throw out a 9. Okay. Sage, did you have something?
Oh, wait, that's right.
No?
Actually, a regular one.
A regular one?
Yeah.
As in a positive one? Okay. I like the regular one thing. Any others throw out there? Here's a hint. None of those are right. Sneaky stuff here. Maria?
Yeah, 5, sorry, 2.
Okay, so Maria used her calculator, which is totally fine. And we have no idea why, but the calculator never lies to us, right? So the answer is 5.25. And that is correct. Wild, right? But it is 5.25. So let's talk about how we would have figured that out, right? Let's say I would have given you this on the front page, and I would have asked you to evaluate this function. So write this off to the side and plug in a -2 for your x. So same stuff we did on the front page. The regular one, as Sage would put it, is the one that I would probably anticipate the most, because I see a lot of people see this and they square it, they get a 4, they see the negative exponents, they're like, oh, it's a -4, -4 plus 5. So the positive one is probably what I would anticipate the most. But again, calculator never lies, right? And Maria is telling us that it's 5.25. So you did this briefly. We will spend quite a bit of time on this later in the year. Kat, you may have said it. What do you think?
It divides
What's divide?
the exponent of x things divide by the amount exponent when it's negative. When an exponent is positive, it multiplies. So the opposite, so a negative exponent is the opposite of that, which is
Okay, I kind of like that explanation actually, and we'll formalize that at some point. Isn't 2 squared 2 times 2? So she said when we have a positive exponent, we're going to multiply this together, 2 times 2, and that would be 4. If I have this as a negative exponent, what this really means, see if you remember this, when you have a negative exponent, we can make that magically into a positive exponent. So let me just make this a fraction. We all agree you can divide anything by 1. If I move this into my denominator, that exponent magically becomes positive. And then now the only thing left over in my numerator is a 1. Now, 2 squared we know is 4. Notice how this is 1/4. That's what I just evaluated right here. So if that evaluates to be a 1/4, 1/4 is like 1/4, right? 25 cents. And then I tack on an additional 5, wouldn't 5 plus 25 cents give us this 5.25? Okay, so kind of weird stuff. So last thing, we'll probably stop here. If we get it right, maybe. If not, I'm going to bore you for the whole time till 10:25. Tell me what f of -1 would now equal. So go to the next one and see if we understand what I just did and see what you think f of -1 is going to equal. I'll even substitute it in so you can kind of see what it looks like. Try to do it without your calculator. All right, ready this time, Sage? All right. F of -1, you gonna walk me through it or are you gonna give me the answer?
I'll give you that.
Okay, so f of -1, what do you got, Sage?
I got 5.5 or 5.50.
5.5 or what? 5.50?
Yeah,
Did you do that in your head or on your calculator?
I do. I did it.
Nice, Sage. Then walk me through it. This is correct. Good. Because 2 to the -1 is really what, Sage?
1/2.
Good. We put that negative exponent into our denominator, so the 2 is now raised to a positive power. So isn't that really just a 1/2? And then we add the extra 5. So 50 cents plus $5 is $5.50, 5.5. Okay, so that's what you're going to put right there. Okay. All right, good. All right, we'll pick up from there. You have no homework tonight. We are going to pick up from here tomorrow. If you did not upload yesterday's homework yet, though, make sure that gets done before midnight tonight. Okay, and then bring this tomorrow. We will wrap this up and work on this a little bit more tomorrow. All right. All right.